Hello students, welcome to another lab for ComSci 137, Data Communications and Networking. In this lab, we're going to talk about packet analysis using Wireshark. For the objectives, you have the following. First, you should be able to capture packets in a live network. So in computer networks, the data that flows along the network are usually called packets, but we've discussed in the lecture that packets actually are called by different names depending on the layer where they are used. And second objective, you should be able to filter display of captured packets, and lastly, should be able to inspect and analyze network packets using Wireshark. So we have the following contents for this lab. Okay, what is Wireshark? So Wireshark is a protocol packet analyzer. It's a network packet analyzer which captures the packets as they flow over the network. So usually operating systems implement a networking stack, specifically TCP/IP stack. So recall in the lecture that the TCP/IP protocol suite has 4 or 5 layers. So we have physical data link, network, transport, and the application layers. Now what Wireshark does is to capture these packets or protocol data units and presents them visually to the analyzer. So what it does is to hook into the networking stack and capture the packets as they move along the operating system and out of the computer. So it says here that it's used to examine what's going on inside a network cable, not necessarily. Just like a voltmeter is used by an electrician to examine what's going on inside an electric cable. Not necessarily, because what is flowing on the network cable is our current, okay? So physical layer, but Wireshark actually can capture data link up to application layer protocols, something like that. So we're going to use Wireshark, and before Wireshark, when I began using Wireshark, it was referred to as Ethereal, but it was renamed to Wireshark, but the same core project. So what are some of the usage scenarios of Wireshark? First, network administrators use it to troubleshoot network problems. For example, HTTP traffic cannot go out of the network, so they can use Wireshark to examine where the HTTP packets are cut off. Network security engineers use it to examine security problems. For example, there is a ransomware attack, and normally in network setup, all the packets that comes in and goes out of the network is usually saved, and they can use Wireshark to analyze this particular packets. Okay? QA engineers use it to verify network applications. So if a company is writing network applications like a distributed database or implementing a proxy, for example, a high availability proxy, then QA engineers can use it. And fourth, developers use it to debug protocol implementations. So let's say you're writing a new messaging protocol, so you can use Wireshark to debug the implementation of this new protocol. and is people use it to learn network protocol internals, which is actually what we're doing in this lab. So Wireshark looks like this. So you have to download and install it from the Wireshark website and install it on your machine, and you will be presented with this interface. So it's divided into 5 main windows, or 5 main parts. The first one is the main toolbar. So it's highlighted here in the handout. This is the main toolbar. Then we have the filter toolbar. Okay. So this is a display filter toolbar. Okay. So you're going to use it to filter so that not all packets will be displayed on your machine. Then we have the packet list pane, which displays a summary of each packet captured. So this is a summary. Each line here represents a packet. Okay. And then by clicking on packets in this pane, you control what is displayed in the other 2 panes. So the green one represents the packet details pane, which displays the packet selected in the packet list pane in more detail. And the 5th one, the bottom pane, displays the data from the packet selected in the packet list pane, and highlights the fields selected in the packet details pane. So that's the idea. So it's quite intuitive when using Wireshark, because the windows are divided cleanly, or the panes are divided cleanly. So the next step is, how do we capture packets? So it depends on your settings. You can capture packets that are coming or flowing through the network if you have a wired network, okay, and you have promiscuous mode. But in a wireless network, usually you can only capture packets that goes in and out of your machine. This is when you open. So let's take a look at the method of capturing packets. The following methods can be used to start capturing packets with Wireshark. You can double click on an interface. So what is in this handout is running on, I think it is running on a Windows machine. So you have to first select an interface. I'll demonstrate this later. Then you can get an overview of the available interfaces using the capture interface dialog box. Okay, and then you can click start a capture from this dialog box using the start button. Now actually, before starting the capture, you can actually specify a capture filter here, which is different, which has a different syntax than the display filter. I prefer to use the capture filter because this will save some processing for Wireshark, because it will only capture the packets that that matches the filter. Unlike if you use the display filter, it will capture a lot of packets and only then can you filter the display. So I recommend that you use this capture filter, and eventually you'll get items like this. Then you have the stop button here to stop the capture. Okay, and they allow you to select packets by protocol, process of field, values of fields, comparison, etc. And you can check out this link for display filters, or you can actually search for capture filters. What I will demonstrate later is how to use capture filters. Okay, so that's the basic use of Wireshark. So let's have a demonstration. Okay, so I have my Wireshark started here. So I am presented with the initial window wherein I have a set of interfaces where I can capture packets. So as you can see, you see a graph here that indicates the activity of the interface. As you can see, the Wi-Fi interface is active because there are fluctuations here. Right, so this is where we're going to start the capture. But first, let's start with capturing a lot of packets. So I double click this Wi-Fi and you will see that a lot of packets are being captured. And I click stop, and then I can use a filter as shown in the slides. So let's say shown here TCP.stream EQ 35. So we can try that. So we can apply a TCP.stream. So there's an autocomplete EQ 35. So there is no TCP stream for that filter. So because maybe we did not capture something. Okay, but that's just one way to specify a filter. Now the other way is to specify a specific capture filter. Okay, let's start, continue. Okay, so here, so we select the interface, and then let's say I would like to capture web traffic for when I access my website. Okay, so this is an example syntax. It says here that capture all packets that has port 443 and goes to this website. So we can start here and continue without saving. So at this point, since I haven't visited my website yet, there will be no output in the capture because I haven't visited my website. But if I visit my website now, then as you can see, the packets will now be shown here, captured packets, and you can select stop, okay, because I visited my site already. So what it did is to capture only packets that are destined to my website. Okay, now let's examine the packets. So although we were not able to cover this in the lecture, TCP is a connection-oriented protocol. So we have connection establishment, then we have data transfer, and we have connection termination. So as you can see here, we have SYN. So the connection establishment process uses a three-way handshake. So you have a SYN, SYN up, and up. So this means that this is the IP address of my laptop. It sends a TCP segment to this host, which is jackhamshire.org, to this port number 443, Okay, so if I click this, you will see that this pane here is actually the encapsulated packet. Recall in the early meetings in the lecture that encapsulation is important in computer networking. So we have frame here, okay, and then Ethernet 2, then we have IP, and then TCP. Okay, so remember that frame and Ethernet belongs to the data link layer. IP belongs to the network layer, and TCP belongs to the transport layer. So you will see that you have the SYN-ACK and ACK three-way handshake, and we can examine actually the fields of the different protocol data units. So you can see here the fields for the IP datagram. You can see here the fields for the TCP segment, and you can see here the fields for the Ethernet frame. Okay, so that's basically the idea, and at the bottom you can see the actual bytes for these values. Okay, so these are actual raw bytes. Now this site is encrypted. My website uses HTTPS. So after the three-way handshake for the TCP, okay, you will notice that the protocol now is TLS, okay, which is Transport Layer Security version 1. And if we look at this, so you can see that there's an additional layer here, which is the TLS, and it's basically the client hello that initiates the exchange of keys. And after that, the exchange will be encrypted. Okay, so that's how we do it. Okay, now let's try to capture HTTP packets that from a website that does not use HTTPS. Okay, so we can do that. Let's go back to the slide. So under learning experiences, okay, so you will see here that, so let's try capturing packets for techpanda.org. So we copy this, and we capture again Wi-Fi, but this time we specify techpanda.org as the host name. And then since we are looking at plain HTTP, so we're going to, okay, so maybe you weren't able to catch it, but let's try. So you can see this window actually, unfortunately. So let's close it. Okay, so you can see the window. Okay, so let's go back to this main interface. Click Wi-Fi, and then this will be our site to visit. So this one does not use HTTPS, so we specify for port 80, and we double click. And at this point, we haven't visited TechPanda yet, so I will go visit the site now. And then what happened? Capture, no data was captured. Okay, so I Okay, capture it. Okay, so now I visited Tech Panda. Then in the handout, it tells us to log in using admin at Google, password 2010. So let's try this. So, okay, I am now logged in into the server. Okay, so let me stop the capture. Okay. So let's take a look again at the three-way handshake. So we have several SYN requests here, probably because it's waiting for a reply. So we have SYN, SYN app, and app. So we now have a connection, and this is an example HTTP packet. So we can take a look at this HTTP packet, and in ComSci 100, usually the HTTP protocol will allow you to have a request method. In here we have a get request method, and then the protocol number, host, user agent, and many other parameters, and some session ID. So this is an application layer protocol, HTTP, so you can see the contents here. Now if we filter by protocol, okay, and then we click this one, okay, if we click this one, this item here, this is the index.php, so you see the parameters here, and then you can examine the rest of the fields of this HTTP protocol. Okay? So you can actually follow the TCP stream, okay, or HTTP stream, so that you can check the different files that have been used. So not much information here. Let's try, let's filter this again using HTTP. We're interested in looking for the password, and here you can see the password, okay, in the form items that I entered. So this means that if you don't use HTTPS, whatever we submit through a form is visible to us when we capture the packet through Wireshark. Okay, so that, I think, ends our discussion on the basic use of Wireshark to analyze different protocols. So I will send to you the specific activity that you're going to do. Now you can actually save this capture, okay, for later analysis. So you can try this, try saving this packet capture, and you can reopen them in the capture in Wireshark for later analysis. Okay, so that will be all.